Hello, today we are going to be doing a quick demo on how to use KX Systems KDB time series database in concurrence with H2O AI's Driverless AI. Now what you're seeing currently is Driverless AI's user interface, which allows you to interact with the server in an easy-to-use manner. A couple quick notes about the demo today is that we've already set up a KDB server. It has some data, as you can see, and is exposed on a certain port. And we also have Driverless AI already running, and the KDB connector is enabled within Driverless AI. The KDB connector is essentially a built-in connector to KDB servers, and as long as you have pre-configured it, meaning Driverless AI, to have access to the KDB servers, it will enable you to write queries to it and return a file back that has the data included. So if I were to do something like test.csv, I can make a simple query to KDB, and it will pull in the data from the server. Now, for the purposes of this demo, we're actually going to be using the Python client. It makes the demo a little bit more streamlined. And so that's what we're looking at here. Now, the first cell that you're seeing here is simply an install for the Python client, which you can download from the UI. In this case, we've already installed it, so we don't need to do that. Next, we're going to import the client and initialize it. Then after that, we're going to use our Python client to create a data set using data that we query from KDB. In this case, there are two tables, one named Walmart train and one Walmart test, that are existent inside the KDB server already, and that's what we're going to be using for our experiment. And if I hit run, it will create the query to KDB, and then also create the data set that is consumed by Driverless AI. And you can see that that's already completed. Once we have the data sets in, we can create the experiment settings that we want. In this case, I've actually set a couple different experiment settings that I would prefer out of the base recommendations from Driverless AI. And then I'm actually going to start the experiment. And we can actually just take a look at the experiment that has been created right here. So this is the experiment panel in the UI for Driverless AI. And basically, as it progresses, you will see a couple different values pop up, including the variable importance of the model, the most recent model that's been generated, as well as some information about how the model iterations have progressed and how your output scores progress over time. Basically, once the model is finished, we will have the opportunity to export the final model, and that's what we are going to be using with KDB. Ticker plant in order to actually take real-time data from KDB and then score it and return that data back to the ticker plant so that the ticker plant can have it consumed by another subscriber. So in this case, we don't need to train another or wait for the final model to be built here because I've already built one. So what we can see is once we've actually gotten the mojo, well, actually what I'll do is I'll show you the command. But basically, once you have the completed experiment, you can build a mojo, which is a memory optimized Java object that will enable you to get it as a downloaded object. It comes in as a zip file called mojo.zip, which you can then unzip into the requisite packages. And then you take the final object, which is right here, pipeline.mojo, and deploy it with a pre-built Java object or Java jar that we've generated, enabling you to subscribe to KDB, get new information from KDB, score it, and then return the scored values back. So I've already got a mojo running real-time scores, and you can see as time progresses that the values here will update themselves. And at this point, we've already processed somewhere in the upwards of 1,000 scores. And finally, what I'm going to do is use a second smaller example that simply subscribes to the new predictions table that is being generated. What this will do is emulate the idea of I have now taken the original data, it has been ingested and scored via the Mojo, and then pushed back to the KDB ticker plant, where ticker plant is now sending this data back to my new subscriber, which I just launched. So if we actually stop both of these processes, you can actually take a look and see that the new predictions here, so we've got a 209, a 223, a 22 odd hundred, and a 209, and that should be within 1 or 2 values up. There you go, right here. So, and please, obviously I stopped this one a little bit later, so there were new predictions that were actually scored in real time that, because I had stopped this process already, were not caught. So that is a quick example demo of how we can utilize data in KDB to create new models and then use that model to score in real time new data and then consume that new data for whatever purposes we want. In this case, it was simply to print it out, but it could be for anything. It could be to serve customers with live updates, or it could be to simply score it back to a relational database so that we can store the predictions for later. Thank you.